Hello and welcome to the second video on hypothesis testing. And in this video, we will look at what is the difference between one-tailed tests and two-tailed tests. So when we do one-tailed tests, we always know whether the probability of the alternative hypothesis is expected to go up or down. But sometimes we don't know if the probability of H1 is going to be bigger or smaller than the probability in H0. And in this case, we have to check both ends of the distribution. We call those ends tails. And in these tests, these tests are called two-tailed tests. So to sum it up, if, for example, H0 was that P equals 0.3, then in one-tailed test, we will have either that H1 will be P is less than 0.3 or P is more than 0.3, but in two-tailed test, H1 will be that P is different from 0.3. When we do a two-tailed test, we always have to halve the significance level because we are checking both ends of the distribution graph, not only one end like in a one-tailed test. But when we do the actual calculations, we only need to check one tail. Why? The best way how to understand is by looking at the graph of the distribution. So this is a distribution where n is 30 and p is 0.3. And the maximum probability of this distribution, as you can see on the graph, is when x equals 9. We know that the p-value that we are looking for when we do calculations must be a small number because we will be comparing it to the significance level. So if the observed value in the test was, for example, 5, let's imagine we have got 30 cars and 5 of them failed MOT. Because 5 is to the left of 9, the region we need to check will be from 5 down to 0. And as we can see on the graph, these are really small probabilities. So this will give us the right small number we are looking for. And on the other side, if the observed value was, for example, 16, which is on the other side of the maximum, so let's imagine that 16 cars failed the MOT, then again, the right tail from 16 until the end, they are all small probabilities, and this will give us the right small number that we are looking for. The best way how to understand is really by looking at an example. So again, you can pause the video, read the question, and then we'll start going through the example together. So here we are testing at the 5% significance level whether the managers claim that the probability has changed is correct. So the first step, as with one-tailed tests, is we write H0. So here the regular case is that about 30% of customers would buy an Apple computer, and the manager is testing, has it changed? So is it different? Now the second step, this is the one which is different from one-tailed tests. We have to find the maximum, the x at which will be the maximum of the probability. The formula which is in the formula book is n times p. And so for this particular question, when n is 30 and p is 0.3, we got maximum at 9. And because there were 30 people who bought the computer, 13 is to the right of 9, as we've seen in the introduction in the first slide. So we only need to check the right tail. X is more than or equal to 13. Now we do the calculations to find the p-value of this test. So again, using your calculator, using the binomial CD button, you get the answer 0.0845, which is about 8.45%. And finally, in step 4, we have to halve the significance level, which will give us 2.5%, and compare it to the p-value. So we can see that 8.45 is definitely bigger than 2.5, which means that the result is not significant. So there is not enough evidence to reject H0, and we have to reject H1. In the context of this question, the manager's claim is actually incorrect and the probability of buying an Apple computer has not changed. So in the next example, you can pause the video and just try to read the question and do all 4 steps on your own. And once you've finished them, we will just go through them together and you can check if you've got the right answers. So let's start now checking the answers. So H0 must be 0.06. That's the number of plates that will have cracks, and H1 is that P is different from 0.06. Step number 2, to find the X where the probability is maximum is 2.4, and because 7 is to the right, again, like in the previous example, we are only checking the right tail from 7 until the end of the distribution. The calculations to get the p-value is 0.00906, which is actually less than 1%. It's a very small probability. And we also have to halve the significance level again, which is 2.5%. And now 0.9, which is about 1%, is definitely smaller than 2.5. So this result is significant and there is enough evidence to reject H0. And we can accept H1. And in the context of this question, it means that the claim is correct and the proportion of cracked plates has changed. So that's the end of this video. Thank you for watching.